Sometimes a centrifugal fan does not deliver steady air. Flow drops, pressure decays, flow recovers, and the cycle repeats with a whoosh or vibration. That may be surge, but sound alone cannot diagnose it. We need the fan, system, and time history together. Stall is local, flow separates from part of a blade passage. It may be intermittent or rotate around the wheel. Surge is a whole system flow and pressure oscillation. Stall can contribute to surge, but does not prove it. At fixed speed, the fan curve relates flow to pressure rise, the system curve relates flow to resistance. Their intersection is the operating point. Stable selection uses the manufacturer's tested curve, approved region, and actual system data, not a generic sketch. Close a damper, load a filter, block an inlet, or change the process, and resistance rises. At the same speed, the point moves toward lower flow. Near or left of peak pressure, the fan may enter an unstable region. Lower flow changes inlet velocity and effective blade incidence. The boundary layer may no longer follow the surface against the pressure gradient. A separation pocket forms, pressure becomes irregular, and the wheel stops behaving like one uniform aerodynamic machine. In rotating stall, separated cells occupy parts of the circumference and travel around the impeller. They can create subsynchronous sound, vibration, and cyclic loading. The whole duct flow need not reverse at once. That distinction matters. System surge needs stored air volume. Resistance rises, flow falls, separation grows, fan pressure collapses, system pressure decays, then flow recovers. If the fan and system return to the unstable relationship, the cycle repeats. Surge is a system problem, not just a wheel problem. Record synchronized flow, pressure, vibration, current, speed, and control command. Surge should produce related pressure flow cycling. One vibration peak or phone recording cannot prove the loop. Preserve time alignment and operating condition. Imbalance follows running speed. Loose parts create impact or harmonic evidence. Control hunting begins with a changing command. In surge, flow and pressure cycle because the fan and system cannot settle. Multiple conditions can coexist, so test each hypothesis. Select within the stable range, preserve uniform inlet flow, define minimum flow, coordinate speed and damper logic, review parallel fans, and validate the operating envelope. Do not address instability by changing one control number without checking the curve. Guarded fan and airflow tests map repeatable flow, pressure, power, and speed. Compare the tested fan curve with the real system curve and time histories. Verify startup, turndown, damper transitions, parallel operation, and required process states. Stall begins with local separation, rotating stall moves it around the wheel, surge is a system pressure flow cycle. Operating point and system storage connect them. For a stability review, send fan and system curves, speed range, controls, duct layout, and synchronized histories.